Hi folks, so today we're going to take a look at some more scripting concepts. Now, you will already be able to do a lot of things just by understanding the basics that we've covered in previous videos, like variable assignment and how conditionals work. A lot of the things you learn from now on are essentially shortcuts to make your code a little bit more efficient and a little bit simpler to read. Still, we'll be covering a ton of progressively more complex concepts over the next two videos. So please let me know if I'm not explaining something as well as I should be. I'm happy to put out any additional videos for questions, clarifications, and so on. The functionality that we'll be creating today is going to start off quite simple, and then we'll slowly build up to a scenario. For the idea of the final state, I'd like to see the following. So as we know, the goblins will start out being neutral towards the player. Every time the player tries to interact with the chest, they will get a different verbal warning from the chieftain about staying away from it. And after the third warning, the chieftain and his tribe will turn hostile and they will attack the player. This seems fairly straightforward as a scenario, but there are actually a few logical steps that we need to take in order to make this happen the way we want it to. So before we start, let's have a quick think about some of the questions that will arise. Obviously, we need a script to manage this behavior. Where does the script go? Well, the actor that's going to be doing most of the work, such as shouting warnings and attacking the player, is going to be the chieftain, so that might seem like a likely place for our script. However, the event that triggers everything is going to be the player attempting to open the chest. So if we open up our chest item and head over to the scripts panel, we see that there are a number of empty script slots available for different purposes. So most interactable objects in the toolset, placeables and NPCs, will have a similar setup. We've already seen this with the aux back in the second or third video. The on keyword before the names of these script slots signifies that each one is an event. So an event is essentially an internal signal that gets broadcast to everything when something happens. So for example, the on death event will trigger whatever the attached script is here when the chest is destroyed. So this is an example of what we call event-driven communication. While almost everything that we do in Aurora will be event-driven, if you're thinking of exploring other game engines like Unity or Unreal Engine, you will need to familiarize yourself with time-driven communication as well. For now, this is kind of irrelevant to our project, so I won't delve into the differences, but just keep in mind that we'll be thinking in an event-driven way for the duration of this course. So our triggering event that kicks off the script will be the player's interaction with the chest. Now, for this scenario, we'd like the chieftain to warn the player every time they try to touch the chest, regardless of whether the player manages to unlock it or open it or relock it, just any interaction with the chest here. We're going to ignore the possibility of the player attacking the chest for now. I think I want to have some different functionality from that, and I think the response from the chieftain and his tribe should be more immediate if the player attacks the chest. So we'll just focus on the player normally, non-violently interacting with it for now. So some of these event signals that you see here, they will overlap. For example, if the player has a key and manages to unlock the chest, on unlock, on open, and on use events will all fire at the same time. So we're triggering all the scripts attached to those, since all three actions are actually happening. The player is unlocking, opening, and using the chest simultaneously. If the player doesn't have the key and clicks on the chest, only the on use event will fire. So this is what we're going to use here. Regardless of what the interaction with the chest is, we always want the attached script to be available. So let's create a new script in onUse. We can do this by clicking the edit button. As always, that will generate a brand new script file for us. When we're thinking about a significant problem, it always helps to split it down into the smallest chunks of functionality rather than attempting to tackle it all at once. Once you have the first piece of functionality working and tested, You can add another bit until you have the full thing written out. So let's think about the basic building blocks of what we're trying to achieve. We're going to need in the future something to keep track of how many times the player has opened the chest. Remember that any variables that we establish within the script get destroyed by the end of the script. So we'll need something to hold on to that data. Also, we need to think about how to make the chieftain say a different line every time we try and open the chest. And we need to think about how after the third try, we need to turn the chieftain and his tribe hostile, and we need to attack the player. Okay, so I think the simplest first step here would be to get the chieftain to say something every time the player attempts to interact with the chest. It doesn't matter if it's the same line for now. What we want to do, first of all, is to make sure our script can communicate with the chieftain object. To do this, as always, we're going to need a reference to the chieftain object. If the chieftain was a part of this triggering event that initiated this script, we'd likely have a shorthand way of extracting that information. So, for example, we can do this for the chest and the player just now because they're both directly involved in that event. So the chest, because the script is attached to the chest, can be referenced by object underscore self. So the chest is the owner of the script. And the player trying to open the chest can be referenced by this special helper function called get last used by. So get last used by simply finds out which object initiated the onUse event, and this is going to be our player who's attempting to open it. Unfortunately, our event and attach script has no idea about the chieftain object. The chieftain is not part of the event's interaction, so we will need to get a reference to him manually. There are several ways to do this, but the most reliable is simply to fetch an object with a unique tag that matches our chieftain. So let's save and exit our script for now. It will compile and take a look at the properties of our chieftain NPC. In the basic tab, you will see that the chieftain has a tag. This is a string identifier used by the engine for locating objects in the world. So tags are used in many different ways, but what we must remember is that they're not unique. So multiple objects can have the same tag. For example, if you had a number of generic goblin NPCs, they could all be tagged just goblin. Regardless, all we need to do here is to copy this tag, and then let's head back over to our script. There are two functions that we can now use to retrieve the chieftain using this tag. The first one is the get object by tag, and another function called get nearest object by tag. Since we only have one chieftain in the world, we're probably not going to have multiple objects with this tag. These two functions will work identically. As a rule, however, I tend to use get nearest object by tag regardless. If you do have multiple NPCs with the same tag later on, this can save you a lot of headache in trying to identify the specific NPC that you want. So let's add that function now. We can see that this function has 3 inputs, only one of which doesn't have a default value. All we really need to provide is the tag of the object that we want to look for. In our case, that's the chieftain. The other two parameters are the source object, which defaults to object self, which is going to be our chest. This is the object that the distance is measured from. So when you're getting the nearest object, you're getting the thing that's closest in world space to your source object. The last parameter is the order of the creature away from the source in terms of distance. So for example, if you have multiple creatures with the same tag, this, as you can see, the default value is 1. So this would get the closest creature. But if you override this, you can get the third closest creature with that tag or the 10th closest creature, or so on. So we'll be using this function quite a bit. If you don't fully grasp it just now, that's absolutely fine. For now, we don't need to worry about multiple creatures. We do only have one chieftain with a unique tag. So we can simply supply that as the only parameter and let the defaults take care of the rest. Now, the next thing we want to do is get the chieftain to talk. If you think back all the way to the second video, we already used a function called speakString to get the aux to say moo. However, speakString is essentially a shortcut that is always immediately called on the owning object. And the owning object of the script, as we know, is our chest. So unless we want our chest to start talking, speakString probably isn't the thing that we want to use in this particular script. Instead, if we search up speak in the function search, we see another likely candidate appearing, and that's action speak string. So let's briefly talk about actions and what they are. If you've ever played something like The Sims, you might remember that if you instruct one of your Sims to do several things, wash the dishes, then take out the trash, then pick up the newspaper, you get a little action timeline in the top left or top right corner, I think. So essentially, they will just queue up all those tasks in their memory, and then they'll go through them in order. Unless, of course, they're interrupted by a sudden desire to go to sleep or a fire breaking out in the kitchen. This type of action timeline is actually incredibly common for basic AIs. So just usually it's not directly exposed, like in The Sims. Our NPCs and even our players will also have these types of action timelines. Each time you direct your player character to go to a location or interact with an object, that action gets added to their timeline and executed. Now, the only thing to remember with this is some actions will override all the previous things. So that's like if your sim suddenly wants to go to sleep, they'll forget about picking up the newspaper and go to sleep, whereas some actions are queued up. So we have to watch out for that. So in this way, we can assign actions directly to NPCs using scripting. You'll see the action speak string has the exact same inputs as speak string from the second video. So let's supply an appropriate warning for the chieftain to shout. The default second parameter, as we remember, is talk volume talk, which is probably a little quiet for a warning. So I think we can override that as well. So let's head over to constants and see what we have available for talk volume. Talk volume shout seems to be appropriate for this. So let's add that as our second parameter to override default. Finally, all we need to do is assign that action to our chieftain. We can do that with the catch-all assign command function. We can see that it just takes two parameters, and that's going to be the object that we're assigning this action to and the action that we want to assign. Since we've set both of those up already, we can just plug them directly into the function. With that done, let's launch a quick test and see if that is working correctly. All right, excellent. So that seems to be working. Our chieftain responds to the player approaching the chest with an intimidating shout. But it really doesn't have much of an effect on our gameplay yet. The chieftain just shouts the same thing over and over again, which is kind of boring. So let's make it a little bit more interesting. So first of all, let's create three different actions. This is going to be three different things that the chieftain might want to say. For now, we can just copy our assign command line twice and change out the text to that effect. If we run this now, all three actions will get assigned simultaneously, and we'll hear the chieftain shouting all three lines at us, which is not very immersive. What we want here is for the engine to remember how many tries the player has against opening the chest. So remember that all information in this script gets destroyed after each time it runs. What we really need is some way to persist the number of tries that exists even outside the script. Now, we've already covered how to do this in a previous tutorial. Do you remember off the top of your head the tool that we need to do this? If you said local variable, you are absolutely correct. We need to attach a piece of data to an object and retrieve it and change it every time the script runs. We also want to test what that piece of data is before running the appropriate line. And there are a few ways of increasing correctness that we can do this using. So we'll go through them in order. We'll do the most basic way first, and then we'll try and improve it as we go. So let's first remember how to retrieve our local variable. Counting the number of times the player tries to open the chest seems like a job for an integer. So let's search up local int in the function search, and we can grab our function get local int. We'll see that this takes two parameters, the object storing our data and the name of the variable. Since we're doing single player, we can technically store this on any object that we want. Again, I'm going to do it on the chest because that makes sense in my head. Obviously, in a multiplayer scenario, you would very likely have to store it on the player character so that each player has their own counter of how many times they open the chest. So we just have to remember that for multiplayer, if we're storing any information, each player has to have their own version of that information. So we need to store local variables on the player. So let's fill in the parameters. I'm going to follow convention and use lowercase n for the variable name, followed by its description. So n use tries seems like a decent name. The number of times someone has tried to use or open the chest. Now all we need to do is fulfill some condition, which is going to be playing a sentence, based on the value of this variable. We also want to change the variable so that every time the script runs, we have a different value. What is it that we use when we want to check if some condition is true or false? Of course, we can use the if statement. So remember that the if condition needs to evaluate always to either true or false. If we simply get the number of tries, that gives us back an integer rather than a boolean. So we need to make a logical statement from that integer that gives us back true or false. Simply said, we can check how many times we've racked up and check our variable against a specific number. So for the first shout, we can do this by saying if get local int ochest n use tries close the brackets, equals 0, and then close the second set of brackets, and open our curly braces. That is, if the number of the local variable n use tries is equal to 0. If it is, we want to execute the code in the curly braces. Remember that even though we've not declared n use tries anywhere at this point, it will always have a default value, and the default value is going to be 0 for an integer. So this will be true the first time the script gets called. Great, so now we can add our speaking line into this code block. But now that this code is run, we also need to change the persisted value of n use tries. Otherwise, it will continue being 0 and we'll get the same sentence every time. So to set it, we're just going to use set local int. We could simply set it to 1 here, but we're actually going to be a little bit more clever about this. What we actually want to do is to increase the count of n use tries by 1. This is called incrementation. There are usually shortcuts for doing this. Unfortunately, because we're using local variables, we don't have access to these. So we're going to make our own shortcut for incrementation. For now, let's do it like this. Set local int, open brackets, ochest, comma, n_use_tries, comma, get local int, open brackets, ochest, comma, n_use_tries, close brackets, +1, close brackets, semicolon. So what we're actually doing here is getting the current value of that variable and adding 1 to it, and then setting that combined value to the variable. Great. So now let's repeat this logic for the other two shouts. We can simply copy paste our statement and substitute the number like so. After the second shout, we no longer need to increment the number of tries, since this is going to be when our tribe actually attacks the player, so it's not going to be relevant for them any longer. So let's quickly fill that out and we can cut to the finished version. Okay, so it should look something like this. The script should compile. However, if we test it just now, we will notice something really strange. The chieftain does all 3 shouts the first time we try and open the chest, and then he only does the third one on all subsequent tries. So why is this happening? Let's try to debug our code. The script executes line by line, and here is where our logic breaks. So the first time we run the script, the local variable n_use_tries is 0. However, after we command the chieftain to shout the first line, we are also immediately increasing it by 1. So by the time our script gets to this if statement, this condition is also true because it's now 1. So we execute the second line and increment our variable again. And you guessed it, by the time we get to the third if statement, our statement is true again because n_use_tries is now 2. So the first time we run the script, all 3 statements get called. On all subsequent runs of the script, our persisted variable is 2, so the first 2 statements get skipped and we can only see the third one. Obviously, this is not the behavior that we want, but this occurs because we're evaluating each if statement as a separate condition. If we instead evaluated them together as a single block, we could ensure that only one of the conditions is being satisfied at a time. This is fairly easy to do. All we need to do is add the keyword else between our if statements. If you remember, else is the flip side of if. When we combine them, we can get quite an interesting logical chain. Rather than evaluating each equation separately, we will still test them in order, but only execute the else part of the statement if the if part is false. So therefore, when we now run the script, it will work a little differently. We can see now if we start running the script for the first time, we will see that n_use_tries is 0. And we're going to check for that in this line. So we're going to check if n_use_tries is 0. It is. So we execute the if block of that statement, and everything else is completely ignored. Next time that we run the script, n_use_tries is 1. The first line here, the first if statement, is now false. So we go to the first else, we skip directly to the first else, and we evaluate this if condition. This is now true. So we execute everything inside this if statement, and we ignore everything after the next else, and so on. So now if we test it again, this should be working the way that we want. All right, so I think that's quite a lot of scripting for one video. We're gonna wrap this one up here. So today we've learned about event-driven scheduling, how to use object tags, the action queue, and the assign command function, and how to properly chain our if-else statements. However, we still have a little bit of work to do with polishing off the script. In the next video, we're going to write our first custom function. We're going to learn about using libraries, and we're going to go over while loops and iterators. As always, if you have any questions or feedback about what we've gone over today, please feel free to leave a comment or send me a message, and I will try and get back to you as soon as I can. So thank you for watching, and I will see you again soon.